Hey everyone. Okay, in this lesson we've got quadratic equation 1.4. So we are actually upping the degree. We're going up to the second degree. So recall that we began the semester session just a couple of days ago by solving linear equations in one variable. We used three principles or properties to solve these equations. What were they? Well, they're so ingrained in your mind that you don't even realize that at one point you learned them. Addition property, which is also subtraction. Principle of equality. Right, so addition and subtraction go hand in hand. And then we've got multiplication. And then what goes with multiplication? Division. Principle of equality. Oops. Ooh, I added an extra T in there, that other one. Oh, hello. And then last but not least, the distribution. AKA factoring. The opposite of distributing is factoring. Factoring. Principle. Or actually, yeah, principle. Principle property. All right, so remember this addition, subtraction means that we can add and subtract to either side of the equal sign. The multiplication division means that we can multiply, divide to either side of the equal sign. And then the distribution and factoring means that we can distribute things in or we can factor things out. So these are all things that at one point in time you did learn. You probably forgot about learning them, but these are the techniques we've been using so far. Today, well, at least in the 1.4 lesson, we are learning at least three more techniques. We've got the zero product principle technique, the quadratic equation technique, and then, I don't think it's last. I don't remember the order actually. But anywho, it is the completing the square. So most of you are going to be familiar with the factoring and then using the zero product principle. You're probably just not used to being called that name. And then next is the quadratic equation, which you're probably going to be pretty familiar with. And then what may feel the most new is, if I can just wiggle, yeah, there we go, is the completing the square. So completing the square takes a little bit of time for students to get used to it, but once you have the technique down, it comes pretty quickly, okay? So if you need help with completing the square, please get help from myself, Math Cats. Honestly, if you just Google completing the square, tons of videos will pop up. There's lots of different techniques out there, so if you find a technique that you like better than what I'm going to show you, don't care at all. More power to you, right? I just need it to make sense. That's it. All right, so start from the beginning. Now we want to expand the types of equations we can solve by considering quadratic equations in one variable. So we still are just set equal to 0, but now a quadratic equation in one variable is an equation of the form ax squared plus bx plus c equals 0. Where a, b, and c are real numbers and a is not 0. So to talk about this little caveat right here, a is not 0. Again, it's not like behind the curtain some secret thing that I'm trying to hide from you. It's just that if a is 0, what's anything times 0? 0. So that means this whole ax squared term disappears. And now you can see all we're left with is bx plus c equaling 0, which is now a linear equation, which means this belongs way back in 1.1. So this little blurb here, it's not saying that it's no math, it's not a secret of why it can't be 0, but if it is, it just doesn't belong under this 1.4 section. That's it. So, this already went over the three techniques. We're going to start off with the first one. So, suppose that a times b equals 0. What can you say about the values of a and or b? So if two things multiplied by each other equal 0, what do we know about at least one of them? at least one of them has to be 0. Right? Yeah. Right? Because anything times 0 is 0. So if something times something is 0, then one of the somethings has to be 0, right? So how can we write this as a property? So I want you to pause the video, try to see if you can write this kind of as like an if-then statement using this definition. Okay, so we have that if A times B equals 0, then either A equals 0 or B equals 0. That's it. That's the property, right? Basically a rehashment of what we just set up here, but in more kind of semi-technical terms. So this is called the zero product principle. The zero product principle. All right, right? Because product means to multiply, and 0 because, well, 0, right? Kind of in the name. Again, remember, the mathematicians back in the day did us a huge solid and said, look, the math is hard already. Let's not make these titles all crazy. So they called it like they saw it, right? So zero product principle means that if two things multiplied by each other equals 0, bingo, bango. That's what it does. So here's 3 examples. So the first example, let's see. Here, if I have number 1, x times 3 plus x equals 0, then I'm going to call x my a, and this whole factor right here, my b. So going by the principle we just created, so if a times b equals 0, which is the setup, then either a equals 0 or b equals 0. Since we don't know which specifically, then we have to take both. So substituting in, we've got x equals 0 and x plus 3, whoops, I kind of commingled that, but same thing, right? 3 plus x, x plus 3, same thing, equals 0. So now on here on the left for a, we're done. Right? Nothing else to do there. For x plus 3 equaling 0, we just solve for x. So x equals -3. So the two values for x that will give us to equal to 0 are 0 and -3. So these are our two answers. And remember, we now put our answers in brackets or squiggly braces to make the signpost of like, hey, I'm the answer, right? Also in the homework, sometimes you'll have the braces given to you in the text box and then you just like number, however many, right? Other times the homework may be just kind of more annoying and just have the text box and you have to remember to add in the braces. Keeps you on your toes in that sense. So pay attention to this when you're in Connect Math, okay? All right, so now, number 2, I would like for you to pause and see if you can work on it yourself. All right, so number 2, remember that if I have x plus 1 quantity squared, that means that I have 2 statements or 2 factors of x plus 1. So we still have our a and our b. The only difference here is that a equals b. So do we really need to do it twice? No, right? We're going to work smarter, not harder. So if you have 2 different a's and b's, you're going to go through it, the 2 versions, the a and the b. But if a is b, don't worry about doing it twice, right? Because it's just a carbon copy. So we've got the same thing, x plus 1, set it equal to 0 because that is our a. And now you solve for x, so x equals -1. Now 3 is a little different because it's not in factored form, right? 1 and 2 are in what we call factored form. 3 is just in its quadratic form. So first we have to factor this. So 3 has a little extra step to it in the sense that we have to factor it first because we need to figure out what is our A and what is our B. What are our factors? Because now, if for the zero product principle, is there a product between two? There is 3 times x, x times x. But as far as factors go, we don't have that. So, to factor, we've got an x and an x, 2 numbers that multiply to negative 28, but add to negative 3 would be, 4 and 7 minus 7 plus 4. If you need help with factoring, like it's been a while since you've factored, in Connect Math, there are nice videos, excuse me, there are nice videos on how to factor. It's in the, I think it's the R chapter, like review chapter, or maybe it's the O chapter for like orientation chapter. I can't remember, but it's the first chapter, like the actual first chapter of the book, if you need help with factoring. Also, if you wanted to do some Googling, the AC method is a tried and true way to factor. If you want to just Google like what's the AC method, that's kind of, it's more of the sledgehammer approach than the guess and check approach, but it'll always get the factoring job done. Anyways, back to 3. So now, do you see that we have our A term and our B term? So we're going to set both of these suckers to 0, subtract the 4, and then add the 7. And that's it. Bingo, bango, you're done. Okay, so that is the zero product principle method.